Hi, in this video, we will do a technical explainer on the DAO attack on Ethereum. To start things off, we'll do a few basic words with basic terms. The Ethereum virtual machine is a decentralized execution engine, which is made up of a lot of nodes that are spread across the globe that run all the operational execution of the machine and maintain the Ethereum state. The Ethereum state effectively is a large data structure, in this case, a modified matrix tree, which maintains all the information about all the accounts and all the contracts on the Ethereum machine, on the Ethereum network. An Ethereum account basically is an entity that holds some Ether. These accounts can send transactions on the Ethereum network and are of two types broadly: a user controlled account, where the user has agency on the account, or a deployed smart contract, where the behavior of the contract is fixed. It's an immutable piece of code that is deployed on the Ethereum network. With that basic, we'll go and understand the DAO attack. The DAO itself was a decentralized autonomous organization whereby users came together and pooled in money for investment purposes or something like that. But the entire process was controlled by a smart contract. It was viewed with much interest at the starting, and it raised a lot of money starting off. It sold a lot DAO tokens and raised Ether in return, which was to be used for investment. In the DAO, there was a clause whereby the users could withdraw their money by something called a split function, where they could put their money in a child DAO. The DAO attack was carried out by finding a vulnerability in this process, by finding a loophole in the code written for this withdraw function. This loophole basically allowed multiple recursive calls to be made to the DAO without actually updating the balance of the user, so a lot of money actually got ciphered off. To understand this reentrancy attack, as it's now called, we have to understand something called the fallback function in a contract. A fallback function in a smart contract is basically a special type of function which is triggered in certain cases. For example, if a contract is called with a certain function, but this function does not exist in the contract, then a fallback function is called. Or if some ether is sent to the contract and there is no receive function for that, or there's no proper call data signature with the trigger, in those cases, a fallback function is called. Now, to receive ether, the fallback has to have a table keyword attached to it. But basically, a fallback function is this. So the DAO vulnerability basically was that, and this is the representative code, this is not the actual DAO code. The vulnerability basically is that here the balance of the user is not updated until the transaction has been completed. So what the hacker uses is a mechanism to corrupt this transaction. They do not have a receive function in their contract, and they create a fallback function, which then further calls the withdraw function again. So what this basically does is that when the withdraw function is called again, the balance has still not been updated because it was a function call which was waiting to be finished. The balance is not changed, and hence the withdraw function will be called again, and the transaction will be executed again. This will set up a recursive loop until the DAO itself is drained of all its funds. And once the draining is complete, the function stops, it returns, the chain returns, and the entire fund is transferred to the attacker. This is basically a broader picture of what happened in the DAO attack. Now, a slight fix of this can be to change the order of operations, whereby, of course, you change the balance first and then do the transaction. This would stop this kind of a chain in its infancy itself. Another way can be to use a withdraw function, whereby you where in a withdraw function in a lock, whereby you place a lock variable, and only when the lock variable has been put to false again will the another parallel transaction be allowed to happen. So for a given account, only one withdrawal can happen at a time. This is a slight but a effective fix for the reentrancy problem. So yeah, we have understood here what actually happened with the DAO attack, and of course, there's a lot of history attached to it as to how the bug was fixed at the time. You know, a team of hackers, white hat hackers, was formed to drain the remaining money and return it back to the users. And then the larger question around the Ethereum hard fork that happened and whether that should have happened or not, and questions about centralized control and should that be even a thing when the blockchain itself, the idea of Ethereum and Bitcoins is to avoid that kind of centralized control. So those questions also exist. But broadly, for the extent of this video, we have understood the technicalities behind the DAO attack and how that can be avoided. Thank you.